So welcome everyone to the Precious Metals online seminar. So this seminar is in conjunction with the Precious Metals solo exhibition that I have been doing at Photofusion. So I'm just going to introduce the seminar. I'm going to introduce the speakers just very briefly, and then I'll introduce each speaker at the beginning of their talk. So this seminar broadly considers the use of precious metals in astronomy, photography, jewellery and engineering. The seminar discusses a range of issues surrounding extractivism and colonialism relating to the current unsustainable uses of silver, palladium and other heavy metals. This seminar is part of my exhibition at Photofusion and is supported by Arts Council England and Patreon. So the speakers we're hearing from today are as follows. Alice Cazenave will discuss her doctoral research and practice looking at neo-colonial resource extraction. Dr. Leah-Nani Alconcel will discuss her experience with metallurgy as a spacecraft engineer and lecturer in metallurgy. Dr. Ignacio Acosta will speak about his copper Geographies project and his collaborative project Traces of Nitrate. Artist Runo Lagomarsino will discuss his project Laplace, entre les murs, a series of photographs and silver sculpture which have been made from silver extracted from photographic fixative. Artist and jewellery designer Charlotte E. Padgham will discuss her jewellery created using 100% recycled sterling silver and discarded silver from photographic fixer. Oliver Raymond Barker will discuss his recent residency at the Exeter Sustainability Institute, looking at sustainable uses of silver within photographic practice. And astronomer Dr. Camilla Hansen will discuss her astronomical research, which demonstrates how precious metals such as silver and palladium can only be formed in high energy stellar events, such as supernova explosions. And finally, I will discuss the work produced as part of this exhibition and Arts Council funded project. So thank you very much Photofusion for hosting the seminar and for hosting the exhibition. It's been a really amazing experience, and thank you very much for everyone who's been able to join the talk and all of our amazing speakers. I'm really excited about this seminar. It's going to be really fantastic. So I'm now going to introduce Leah, who is one of my collaborators for this project and has been doing a significant amount of collaborative projects with me in this exhibition, including reclaiming the silver and also making the microscope photographs. So Dr. Alconcel is a spacecraft engineer and aerospace engineering course lecturer in the School of Metallurgy and Materials. She has research interests in payload instrument development and calibration, data management for space, and pedagogical methods for inclusive STEM teaching. She has over 14 years of experience working as an engineer and manager on planetary exploration missions throughout the solar system, including the Cassini mission to Saturn, JUICE mission to the Jovian system, and the Cluster multi-spacecraft mission investigating the Earth's magnetosphere. She has worked on the full life cycle of space missions, from concept and design through to build, launch operations and end of life. She has long-standing interest in both photography and public engagement in science, and she's developed and delivered outreach activities for the Royal Society Summer Science Exhibition, Imperial College London, and many other school events and festivals. She's passionate about inclusivity in STEM teaching, and particularly in aerospace and space engineering. She actively strives to recruit and retain a diverse student cohort to the school's courses. And as well as the collaboration that we did with the Precious Metals project, we also collaborated on the Royal Academy of Engineering project, Engineering Sustainable Photographic Processes. So it gives me great pleasure to introduce Leah to you, and I'll now pass over to Leah.
Oh, thank you very much, Melanie, for the introduction. I'm going to share my screen. I have a very small number of slides that I'm going to sort of talk around. So I shall start with this one. So I don't know if people are familiar with this particular space mission. Melanie did mention it in the introduction. This is a mission called JUICE, and it is going to be launched next year in August of 2023. It's been built. It's currently being integrated onto the rocket that will take it to Jupiter. And it is going to be the first ever spacecraft to orbit one of the Galilean moons. So it's going to travel to Jupiter. It will go into orbit around Jupiter. Then it will transfer to Callisto. And finally, it will end up orbiting around Ganymede. So its purpose is to study these big moons around gas giants and try to come up with some general conclusions about whether or not they could potentially be habitable places. So as people probably know who are space nerds in the audience, the Galilean moons of Jupiter include Io, Europa, Ganymede, and Callisto. Io's probably not habitable. It's very close to Jupiter. It's really, really volcanically active, and it's just not a very friendly place. Whereas the other three moons are very cold on the surface. They've got icy crusts, but all of them are known to have subsurface oceans. So what that means is there's tidal heating that happens between the crust, the ice crust, and the core of the moon, and this basically creates an environment where you have a rather thick layer of liquid water in between the surface of the moon and the core of the moon. So Ganymede is particularly interesting out of these because not only does it have this subsurface ocean, it also has its own magnetic field. And one of the reasons why life exists on Earth is because of the strong magnetic field of the Earth. Protects us from radiation and energetic particles coming off the sun. So we know that kind of one of the conditions for life to have developed on Earth was for it to have a magnetic field. So actually a moon that has its own magnetic field makes it extra interesting from that perspective. So why am I telling you all this? I worked on the build of the JUICE spacecraft. I worked on the build of one of the payload instruments that measures the magnetic field, which is called a magnetometer. And it's interesting from a materials perspective, even though I didn't help to develop the materials that the magnetometer is made of. Developing anything for space, any instrument, any spacecraft structure, a rover, anything like that, or a rocket, anything that goes into space, has very rigorous considerations around the materials that can be used in those instruments, in those structures, and in the rockets. So sorry, something coming outside. Okay, stop. The measurement and the understanding of how materials perform under really extreme conditions, whether that's the sort of thermal and mechanical stress when you launch a rocket, or the very harsh radiation environment in space, help to determine whether or not your spacecraft or your rocket or your instrument will survive during the course of the mission. Now, when you go to the outer planets, it takes a really, really long time to get there. So the JUICE spacecraft, once it's launched from the Earth, is going to take about 7.5 to 8 years to travel to Jupiter, depending on what date it actually launches on. So before it even starts its mission, it has to survive almost a decade in space. Hopefully it helps to illustrate why it is so important that we test our materials and we choose our materials really carefully to make sure that by the time it gets there, everything on it still works. So when I was working on the JUICE mission, when we were building it, I was what's called a product assurance manager, which is not a very thrilling title. I fully admit that. but one of the weightiest responsibilities that I had was the materials, mechanical parts, and processes assessment for the instrument. Now, what that means is that absolutely everything that's included in it has to be tested. All of the properties of it have to be either tested or have to be proven somehow, because they've been used previously, for instance, on another space mission, that they will survive. So these are some pictures of different types of different space instruments that we built in the lab that I worked in. The one on the left-hand side, hopefully you can see my mouse pointer, is the Cassini flux gate magnetometer. So the electronics board you can see here has all these wonderful old school analog electronics on it, which have now been completely replaced by a digital design that's about a quarter of the size. So there's another example here, the one on the upper right, of a much more recent version of this flux gate magnetometer. And not only has the sensor, which is the shiny bit here, well, the shiny cap of it here, gotten smaller and turned into these little metal boxes. The electronics box is much smaller than this board ever was. And again, there was a lot of materials testing that had to happen in order for this transition to take place. So each of these electronic components is made of loads and loads of different types of materials. Some of them are metallic and some of them are not. And when you put them all together and you pop them in a little case, you have to test them really thoroughly to make sure that they're going to survive not only the thermal environment, but in particular the radiation environment. And the radiation environment around Jupiter is pretty harsh. Jupiter's magnetic field is 10 times stronger than the Earth's. So down here on the lower right, this is an illustration of a core of a flux gate magnetometer. So this is the bit that actually makes the sensor work. So there's this highly magnetic permeable alloy in the middle here. That's the blue and green part of it. And then it's wound around with some wires, pretty much, some metal wires, and a current is driven through it. And then there's also another winding of wires around it that senses the magnetic field. So the reason why I'm talking about this is just to illustrate how there's these highly complex materials made of lots and lots of different types of metals, some of which are very rare and very difficult to extract, that go into these the equipment that you put into space. And we don't have any way of retrieving it. So once we put it in there and we shot it out into space, we don't get it back. That's a one-way process. So I thought I'd finish by just saying a little bit about what my favorite types of materials are. It's not necessarily the magnetic alloys. There's a couple that I'm really quite fond of, and I'm illustrating them with some pictures here of them being used in space structures. So aluminium is one of them. The process of extracting aluminium is actually expensive and not particularly pleasant. But it is, if you don't shoot it into space, quite effective to recycle. It's quite light. It can easily be combined with other metals to make space-worthy alloys, and it's really, really great at shielding sensitive electronics from radiation. The other one that I wanted to mention before I stop, is stainless steel. So this picture here, up on the upper right, shows the different iterations of SpaceX's Starship rockets. And you can see the first initial concept design for it. It was clad in carbon fiber. So carbon fiber is very, very light. It's much lighter than stainless steel, which is very heavy. So stainless steel, prior to this particular application of it, is not really used all that much in space. However, it's also the stainless steel cladding, and you can see how much of it is on this rocket. It's really big. Is much cheaper. And additionally, if you alloy the steel with lots of chrome and nickel, it becomes very tolerant to extreme temperature conditions. So it has actually quite a high toughness, which prevents small cracks from forming when it gets really cold. So there's a few materials that we develop for space, which I think are nice examples of how we can use materials better, and if not necessarily sustainably, because well, most of them we don't get back. Starship, actually, we will get back. That's the whole point of making it out of this cladding, is that the whole thing returns when it comes back to Earth. So I'm hopeful that as we move forward, kind of in space research and particularly space engineering research, that considerations around sustainability and reusability are coming more to the forefront than they used to. Certainly, it was never, I think, never really as quite as much of a concern as it is now, how much we put into space and the fact that, you know, some of it will never come back. So, yeah, I thought I'd finish there. I think it is improving. I think our attitude towards space and towards material usage is improving. So I'm hopeful that in the future we will be more mindful of in our materials selection.
Thank you so much, Leah. That was fascinating. It's great to hear about how the space industry is thinking about sustainability and moving forward with sustainable research. I'm going to move now on to Alice Cazenave's presentation. So Alice can't be with us at the moment, but she has sent a recorded presentation for us. Alice's research and photographic practice engages with shape-shifting forms of silver. Silver grounds the magic of analog photography. It is the essential light-sensitive element of photographic negatives. Silver exists in specific territories and is mobilized across the globe to enable media culture. And we live in a critical time where media culture and pollution are affecting people and places in disproportionate ways. Working with silver miners, Kodak engineers, conservationists, and indigenous peoples, Alice explores colonial histories of silver extraction, its toxicity, and how it changes worlds and climates. Her work combines photography with other kinds of multimodal engagements to invite audiences to collectively reflect on how photographic materials entangle with the Anthropocene. Many disciplines use visual media to help us understand the Anthropocene. Alice's research considers hidden relations between images and environments, looking at the materials that constitute media and how these contribute to the Anthropocene in delayed and dispersed ways. Alice co-develops a sustainable darkroom, an artist-led research community that works towards devising lower toxicity photographic methods and praxes. In her photographic work, Alice uses plant matter to mediate on the links between ecologies and photographic materials in which plants, minerals, and metals are produced, retained, and recycled by ecologies to enable photography and its material base. So I'm now going to share my screen and play Alice's presentation. So let me know if you can't hear this or can't see it, but I think you should be able to see it quite well.
Hi everyone, it's Cazenave. I'm here today to speak a little bit about some elements of my PhD research. Thanks for the invite, Melanie. It's also great to speak alongside the other speakers whose work I've been following quite closely over the last few years. Today I'm talking about some of the legacies of analog photographic industries. And by legacies, I mean the kind of impacts of the chemistries and the materials used in analog processes, with a focus on photographic silver. So for anyone who doesn't know, silver is the essential kind of light sensitive component of analog photography. It's coated on the papers and films to make them sensitive to light. It's the silver of the silver screen, and the reason why black and white photographs are known as gelatin silver prints. So I'm looking at the chemical legacies of photographic silver, its toxicity, and the pollution associated with it, but also the social legacies and how photographic silver affected people and continues to affect people and places in delayed and dispersed ways, in negative and in positive ways. So I'm thinking through where silver was mined from, who benefited from analog industries, and how environments and ecologies changed as 20th century analog industries grew. And this is all part of my research in visual anthropology at Goldsmiths. So alongside my doctoral research, I work at the Sustainable Darkroom, which is an international artist-led research community that works towards developing lower toxicity alternatives to traditional analog processes. So I'm also a photographic artist, and I work a lot with plant matter, either for photographic chemistries or for printing onto, as you can see in the image here. So I just wanted to say a quick few words about where silver comes from. So obviously it's a metal, it's ancient, generated billions of years ago, before the Earth was born, during supernovas. Really ancient. It's also immediate. It's in the hardwares that enables us to talk to each other now. So it's a sort of matter that travels across universes in weird and wonderful ways. It's distant and intimately connected to us, to the way we see each other and to the way that we communicate with each other. Silver also has a history in helping us understand and visualize our own planet. So photographic silver enabled the first images of the Earth generated by Kodak technologies, which you can see in the bottom image. So silver kind of lives in the ground. It comes from the Earth, but it also mediates our conceptions of the Earth through photographic images. So photographic silver then, with its kind of cosmic origins, helps us understand the cosmos. So I'm interested in how media mediate, how imaging technologies contour how we understand the Earth, how they map the Earth and visualize it as a resource to be mined and exploited, often for technological industries. So I'm interested in silver as this kind of technological metal, and how media and landscapes exist in a kind of double bind. So by this, I mean the ways in which landscapes enable media through the metals and minerals that they produce, and how media enable our conceptions of landscapes through the images that they generate of the Earth and its environments. So my interest in photographic silver then originated from my practice in analog photography and my interest in the materiality of photography. And since working with the Sustainable Darkroom, I've been tracing the kind of material base of photography and looking at where the silver comes from, where it goes to after use, and the people and places that it entwines with on its journeys. So as part of this, I'm looking at Kodak and its manufacturing processes in the US. So in starting my PhD research, I followed Max Liboiron's invitation to look at the structuring logic of your own discipline and forms of knowledge creation, to see what its land relations are, what might be colonial about it, and which naturalized and seemingly benign techniques grant access, moralize maximum use, universalize, separate, produce property, produce difference, and maintain whiteness, which is a quote from their book, Pollution is Colonialism. So the project is looking at silver, but also at some of the colonial histories of silver extraction and some of the Native American lands on which Kodak was built. So I'm following this to think about the ways in which colonial thinking persists today, often used to justify contemporary practices of pollution associated with big industries. So this forms part of a larger inquiry into the legacies of photographic industries and the ways in which precious metal extraction and processing entwines with climate change and the Anthropocene. So my interest in sustainability then looks at the Anthropocene as a complex mix of social, economic, and colonial violences which underpin or provide foundations for environmental injustices, which we see in the form of pollution and ecological destruction. Okay, having said that, you know, obviously I appreciate that for many people, big industries like Kodak provided economic stability for many generations of families that worked there. So I'm thinking about Kodak's impact in Rochester, in upstate New York, and I'll speak a little bit about that later. So just a bit of historical context. My own research tracing silver is focusing on the US. So silver mining boomed in the US in the kind of mid 1800s alongside European developments in photography. So at this time, alchemists and scientists were experimenting with base metals to generate the kind of first photographs in the 1800s. Silver in the US was extracted in the West, often from Native American lands in places now known as California and Nevada. And Nevada was actually known as the Silver State because it had so much silver. Water too was extracted from Native American lands and redirected to Los Angeles and its growing white settler population. So it's here that some of the world's first cinematic industries developed in LA. And please check out Metabolic Studios' work on this. They've done a lot of work at looking at the links between water extraction and photographic industries in LA. So you can have a look at their optics division if you're interested in that. So to enable Los Angeles and its growing cinematic industry in the early 1900s, water was extracted from Pecheta Lake, sort of now known as Owens Lake, and it was siphoned from these Native American regions along a huge aqueduct built in 1913, which is pictured here. This extraction occurred in Payahanadu, which is now known as Owens Valley, and the region sits within the Inyo Mountains in California and is the ancestral homelands of the Paiute and Shoshone peoples. So Chris Taylor reminds us that the arrival of industrialization, ushering in the Anthropocene, is marked by the human ability to move vast quantities of geological material. That's a quote. So in other words, geological projects like mining or dam building, for example, destroy ecologies, but also enable infrastructures and industries which contribute to changing climates in complex and dispersed ways. So the building of the LA Aqueduct was one of the largest projects in geoengineering ever to be attempted globally at the time. It was huge. 13 years after its completion, the LA Aqueduct drained all of the water from its source. So yeah, 13 years, all of the water was removed from the lake, from Pecheta Lake, which is now desiccated. This image here. So by the 1990s, the lake was the United States' largest single source of toxic dust pollution. And again, Metabolic Studios have done a lot of work with this, so feel free to check them out. So part of my research then traces the historical movement of media-related materials like silver and water to think about how these practices affect socio-ecological futures. So that was some background into the kind of colonial relations surrounding photographic silver. I'm moving now to discuss the industrial processing of silver to make the analog films and papers. And this takes me to the east coast of the US, to Kodak Park in upstate New York, which was the world's largest analog manufacturing plant, active from around 1899 to 1970s-ish. Okay, so Eastman Kodak was founded in 1892 by George Eastman and Henry A. Strong in New York. And their main manufacturing plant was located in Rochester, and it employed over 15,000 people at its peak. So the manufacturing site was a huge park with over 254 buildings, spanning over 2,000 acres of land. So this was a facility with the infrastructural complexity of a small town, and it was bounded by the Genesee River on its eastern side. Within the manufacturing site, there were many sub-complexes which dealt with chemical storage, chemical recovery. There was an on-site wastewater treatment plant. There was an electric generating plant. It had its own hazardous waste management facilities and 2 waste incinerators, which you can see the chimneys there, which were burning chemical waste. So yeah, as I said, it's important to say that Eastman Kodak Company was considered, you know, an economic savior to the region, which didn't necessarily have too much industry at the time. And many people that I speak with who grew up in Rochester are immensely proud to have been part of this history and are grateful to the industry for providing them with lifelong employment. So I don't want to provide a binary argument here. So I'm just including that in the brief explanation of what I know so far. Having said that, there are some controversies surrounding Kodak. For decades, toxic chemicals leaked from the site into the earth and into water systems nearby. So in 2005, the site was investigated by the New York State for chemical pollution. And the investigation found that the groundwater under the solvent storage site was contaminated by around 68 different metals, chemicals, and what's known as volatile organic compounds. So volatile organic compounds are important chemistries because they move. They're volatile, they're difficult to contain, and they move through ecological systems. So of the 17 volatile organic compounds detected, 5 were classified as either possible, suspected, or known human carcinogens. And methylene chloride, which is the key chemical used in photographic film production, exceeded at kind of acceptable limits by a factor of 162,000 times over. And this is considered a potential human carcinogen. And that's the one I've highlighted there from the research paper. Silver also exceeded acceptable, in inverted commas, limits by a factor of 1.8. So silver is not toxic to humans necessarily, but it's thought to be considerably toxic to marine life and microbial life, which is important in this context because of the Genesee River, which borders Kodak Park. So in engaging with Kodak, I'm thinking about how silver travels through bedrocks, geologies, and bodies of human and more than human kinds. So it's this idea that media toxicants travel, but sometimes they stay put. So some of these media toxicants lodged into the bedrock below Kodak Park. And I don't know, I find that interesting working in photography, because the earth then becomes a kind of recording medium itself, recording the chemical legacies of media cultures in its literal rock matrices. So other chemistries migrated through the rocks into groundwater systems, and this is from the 2005 geological report. And yeah, migrated through the rocks into the groundwater. And the groundwater is particularly important to think about in terms of contamination, because it's used for lots of things, including drinking water. So only 1% of the Earth's water is usable by humans. And of this 1%, 99% is groundwater. And the environmental report concluded, and this is a quote, that migration within the bedrock at Kodak Park appears to be strongly attenuated. So the migration was slow, and this resulted in the scientific conclusion that, and I quote, contaminated groundwater is stabilized. So in other words, because the contaminants were moving slowly, they were considered stable. And this slow or non-critical condition is important, and it links to what Rob Nixon calls slow violence. And this he describes as, and I quote, a violence that occurs gradually and out of sight, a violence of delayed destruction that is dispersed across time and space, an attritional violence that is typically not viewed as violence at all. So part of my research then is unpicking the systems and violences that are implicit in our vision technologies. So this involves the violences associated with precious metal extraction, as well as industrial sort of processing and pollution. Okay, so I'm going to talk a bit now about some initial research that's being done into sort of generating circular systems within darkroom spaces to help manage chemical waste. So part of this involves removing waste silver from chemistries, which some of our other speakers are talking about today. And there are a few ways of doing this. And as I mentioned, this is really important because silver is highly toxic to microbial and marine life in certain forms. So pure metallic silver, as I understand it, is inert and not dangerous. It only reacts with and kills microorganisms when it's ionized. And this ionizing occurs in aquatic environments, at wastewater treatment plants, for example. So silver ions can enter microbes and interfere with their molecular processes, killing them. So this is significant because microbes are often put into wastewater specifically to digest and clean sewage. So without them, wastewater management processes risk becoming severely compromised. The other important thing to note is that silver is the most widely used nanomaterial, present in over 435 commercial products, and I think that's most likely on the up. So silver nanoparticles are woven into textiles, technologies, and cosmetics. So there's a lot of it about, basically. So I'm thinking about how to remove silver from waste sites, and a few researchers are looking into phytomining. So phytomining is the absorption of metal nanoparticles through plant roots. So the plants literally mine the metals from the earth to remove them. And the idea is that plant bodies could remove toxic nanoparticles from the earth and prevent them being absorbed by other bodies, such as microbes. And having spoken with scientists about this, it's become evident that you would need like a forest of phytomining plants to clean a small dark room's worth of waste. But I still think it's an interesting concept that I'm going to pursue. And I quite like the idea of this more than human trafficking of photographic silver, inspired by Ignacio's title of some of his work that he's done. This idea of trafficking, of the movement of the silver through different bodies of human and non-human or more than human forms. So, as I said, for me personally, I think it's interesting conceptually to think about positive plants growing out from negative soils in which a plant emerges from kind of silvery soil, mimicking the kind of photographic relation that a positive image has with its negative. So almost all plants can be used to make photographic developers. So I'm interested in how darkroom waste moves through ecologies and can be reconfigured to make new, sort of lower toxicity plant-based chemistries. So my first experiments with phytomining will be with Brassica junica. I don't know if I've said that correctly. I'm not hot on Latin. So my intention is to plant photographs so that the brassica can use the photographic silver as a source to grow. And as I said, quite a few researchers are looking into this. So that's one element of some of the work I'm doing with silver. And this forms a kind of broader engagement with circular systems of darkroom waste management, where waste can be fed back into ecologies in ways that are hopefully more beneficial to those ecologies. So as I mentioned, alongside my doctoral research and photographic practice, I work with the Sustainable Darkroom, and in 2021, we set up a photographic garden residency where artists could propose projects that use the garden in some form in their research. So for instance, Alice Campos is researching the role of oyster mushrooms in breaking down plastics coated onto photographic papers with an aim of kind of finding solutions to, breaking down waste paper. Michaela Davidova is creating structures which mimic wetland architectures, but on a micro scale to filter waste darkroom chemistries, and I think she's working with cyanotype wastewater. So I think I'm actually out of time, but feel free to look up the Sustainable Darkroom if you're interested in joining a community that researches and works towards lessening some of the toxic impacts of analog processes, amongst lots of other things. Thanks again for listening, and feel free to contact me for more information on the Sustainable Darkroom or anything else for that matter. Thank you very much, and thanks for the invite, Melanie.
Wow, that was absolutely fascinating. Yeah, very inspiring. I'm now going to introduce Runo Lagomarsino. So Runo was born in Lund in 1977 and lives and works in Malmö. Recent solo exhibitions have been held at Lunds Konsthall, Moderna Musik, Stockholm, Dallas Museum of Art, La Criée Centre d'Art Contemporary, Rennes and Malmö Konsthall. He has been featured in group exhibitions at Dard Gallery Berlin, LACMA Los Angeles, Fondazione Trussardi Milan, Museum of Contemporary Art Chicago, the Guggenheim Museum New York, and Museo Reina Sofia in Madrid. He has also participated in the Guangzhou Triennale and the Guangzhou Biennial, the Venice Biennale, the Istanbul Biennial, the Sao Paulo Biennial, Prespa New Orleans, the Gothenburg Biennial, and the Ural Biennial. And in 2019, he was awarded the Friends of Moderna Musik Sculpture Prize and was DAAD Artist in Residence in Berlin. So I'm going to pass over to Runo now. Thank you very much.
Hey, thank you, Melanie, for the invitation and for the other speakers. It's been really interesting. And I will talk especially focusing on one specific work, but I will also give a short introduction on the way I operate, or the kind of the way, like the structure and the kind of where this idea of materiality comes from in my work. As Melanie said, I'm an artist based in Malmö in the south of Sweden. I work with a range of media, such as installations, sculptures, photography, and actions. And I think my work in some way searches for fractures or for blind paths from where to tell other stories. I try to point towards the gaps and cracks in the kind of the structural models of the models with capital M, no? And truth claims, highlighting language precarious foundations, as for example, in the effects of violence and dominance. In my case, I'm also focusing a lot on the kind of the colonial history of Latin America and the way the transatlantic connection between Europe and South America is not a past, but it's a constant present, I would say. I would say that my work, or the work, focuses on the possibility or the impossibility within our forms of narration. And I've seen kind of materiality as a potential narrator to look at history, to look at memories and memorialization, to look at the links between the past and the present, to look at how history haunts the contemporary, and to look at how the geographies and colonial relations are conceptualized. Language and geography and historiography are themes that I revisit in my practice, using materials that often evoke memories of our past, only to us to reflect on the conditions enabling this connection. Can a material be a narrator, a form of witness? What traces and memories can a material carry? Can a material speak? And if so, what is it telling us? And also further on, paraphrasing Spivak, and do we listen? Can it speak, and are we listening to it? No. And I think it's not solely about letting the material speak, and not just about speaking with and through the material. It's rather an act where the materials are made witness and are thus given their due, meaning that the question at hand are incorporated in matter in a literal way. So I think for me, this is a very central question. It's a shift for me of moving from forms of representation to an actual position where the materials are there, kind of in a way the first witness and the first viewer of a work, but also the first subject of the work. You know? And I think this kind of interest in the possibilities of materiality also comes for me when a kind of the travel that I made for many years between South America and Sweden, no? And especially Brazil, which was my home for many years. No? This movement between South and North kind of forced me to re-articulate these questions of the possibility of narration and the ways of how materiality can operate. No? I will share and I will show you this one work that I was in a way asked to present here, which of course makes a lot of sense connection to the thesis of silver photography. You know? It's a piece called La Place entre les murs. The title comes from a novel by Marguerite Duras, the French writer. And in translated it would be the square between the walls, which it's not as beautiful as in French, because the idea of place and place, of course, has a different meaning than square. This is how it looks of one of the presentation, and it consists of 14 gelatin silver prints and extraction of silver from a photographic fixture. And this is the starting point of the work. This is a black and white photograph that was taken on board on the boat or the ship from Argentina to Spain in 1976. So actually my father and my mother and my sister are in the picture. I was born the year after in Sweden. And there is this kind of paradox in this image, because in a way, it's like this kind of classical tourist picture, everybody's smiling, but this is in 76, it's the same year after the coup in Argentina. So they're leaving one of the deadliest dictatorships in the history of South America. But in a way of also pretending that everybody was visiting Fiat, they were visiting Rome or visiting France, but of course, most of them were escaping or fleeing. You know? So in a way also here, for me, there's this kind of, this is in a way, the punctum of the exile moment. This is the image of that construction of the exodus in some way. You know? So when I started to think, okay, how can I create a work about to narrate this position of exile and movement and displacement, and also exactly, and it's also not how can I avoid forms of illustration, but how can I make a work that connects and tells these stories without forms of illustration now. And this is some of the text I started to when I was working with it. You know, images sometimes as people disappear, which of course is connected also to the military times in Argentina, where people were killed, but they were called disappeared. You know? And it's still a very common use of word, los desaparecidos, the disappeared people, you know, in Argentina. Images sometimes as people come back to life. The impossibility just takes a bit longer, says the alchemist to his material. The impossible just takes a bit longer, says the mother of Plaza de Mayo to the shadows of the past. Hope and fear are the geometry of the alchemist. Alchemist as in Victor Grippo's potatoes and as in August Strindberg's celestography. Can you make Argentina from an exile point of view? Can you extract silver from Argentina? The exodus of an image by repeating it. The impossibility of finding the essence of the image. So here is the other part of the work and the photos, and this is the silver. No? So what I did is I printed, like I used, as you know, black and white, as several people have mentioned, contains silver. No? So I used an analog lab and we printed the picture 40 times. 40 times was the time space between when the picture was taken and the moment when I made the work. There was also some of which is not only there is also a conceptual, but it's also the years of the exile in a way. So I think that kind of was also incorporated in the possibilities of the work. You know? And here I started to think. I used the history or that Argentina, the name of the country, comes from argentum, which means silver. No? There is this saying that, of course, I don't know, but it's not true, that when the British came to Argentina, the lake, the sun was throwing the sun on the water, so it was flickering like silver, and then it was called Argentina. So I kind of combined the name of the country with the use of silver prints of photography. You know? And then and then we printed the pictures, and then we saved the fixative. And of course, when we did it, was this kind of very important that my fixative could not be shared with other fixatives, which of course was this kind of complicated to explain. But of course, in the end, we managed to convince the lab, but I couldn't. It cannot be contained with other fixatives. You know? So then, and then after we printed all the picture, we extracted from the used fixative this piece of silver. So in some way, this is what is left, or this is all the materiality of all these pictures, or in a way, this is the materiality of the possibility, or in a way, the impossibility of narrating forms of exile. Form can give us access to things that we have experienced but not registered, or have registered and not then forgotten. I think here there's this, for me at least, that's why I come back again, again, towards forms of materiality as a tool of discussing questions of migration and politics, for example, that there is a potentiality with materiality in some way, because you can use them, they carry a story in a way, you know. And I will also give a short explanation. August Strindberg, I don't know if you know him, he was a Swedish, very important Swedish writer. Like he's kind of considered one of the first modernist writers of Sweden. But he also worked a lot with photography. And Strindberg, this is his celestography from 1893 to 94. He distrusted camera lenses, which is really early on to imagine that he was already then very critical towards the production of image with a camera, no? Because he considered them to give a distorted representation of reality. And over the years, he built many simple lensless cameras, like pinhole cameras, but also these ones, he just had these metallic plates with an emulsion, and then he said he put them on the street, and then he said that the colors and the print was just by the light of the stars, by the sky. And also they included a letter in French, which now people think it was to a French astronomer called Camille Flammarion, and it says, sans appareil ni lentille, without a camera or a lens. For me, this works by Strindberg has been very inspiring in a way to think that there is this form of history, and there is that the plate or the photographic structure carries the story. It's embedded in the actual plate. And the other one I just mentioned shortly is an artist called Victor Grippo. He was one of the most influential Argentinian conceptual artists from the 60s. No? And he also he studied chemistry before he became an artist. And what he's mostly famous with is this works where he shows that potatoes, which is not only Latin Americans, but many, it's one of the most common food that they have an energy. You know? So this is an example of the works he made. And here, I can show you short. This is the. This is a short image of how we made the extraction. So that was it's a fixative, and we had a plate that then by spinning it drew all the dust, which later on, of course, this is the silver dust, no? So that I just wanted to show you shortly one of the how we retracted it. I think it's also interesting to think about for 40 years ago, maybe even less, and at least in Sweden, it was very easy and very common there was a lot of places where you could extract silver. When I made this work, it was super complicated to find somebody who wanted to do it or had the knowledge to do it. So there is this, of course, there is this time shift. No? Here is the work installed in another exhibition at the Lunds Konsthall, which was the show that Melanie mentioned. And there is the silver. I think there is this, for me at least, this important Valeria Lucille, which is a Mexican artist. She wrote in her last novel, I think I finally begin to understand. I think this plan is to record the sounds that now in the present travel through some of the same spaces where Geronimo and other Apaches in the past once moved, walked, spoke, sang. He's somehow trying to capture the past presence in the world and making it audible despite the current absence by sampling any echoes that still reverberate of them. And once again, this is like, I think there is this, how a material and how a forms of artistic practice can use recordings in, Valeria is a writer, but she used an example of recording. In my case, I use the silver as a way of narrating the impossibility in a way of creating a work that tells the story of a specific form of exile. No? I will end by jumping, I think, almost 10 years back, showing shortly a work that I made, which was called Transatlantic, which I always call this work sun drawings, but they are actually photographic prints by the sun in a way. But I think they also encapsulate kind of the way I try to operate and the way I kind of believe how this, in a way, very complex questions of displacement and colonialism and migration can be, in a way, you can try to avoid representation, but at the same time, create works that embedded this question. And when I did this, I had a friend, he was a sailor, like as a hobby, he sailed across the world by a boat, on a boat. And what I did, I gave him 50 paper, like newsprint paper, monochromes that didn't have any information on them. And you see one on top of this deck, no? He strapped them on the boat like that. And I just told him that when he was crossing from South Africa to Brazil, he would just put the papers on deck, and he could choose the way he wanted to do it. Like as he sailed alone, I couldn't control how many people he would put up on in which way or how many times. So I just gave him and said, okay, this is so. And then he started to put them like here, as you see in the image, on the sailing boats, plastic strap, like during the whole crossing from South Africa to Brazil. But what was interesting also that he went all the way up to the same positions as the colonial travel went. So in a way, he went up almost to like Gambia and Guinea-Bissau, and then he crosses. So I think for me it was this work that kind of, in a very subtle way, connected like the history of Brazil and the connection between the slave trade, but also my own constant traveling between crossing the Atlantic, and also focusing on the idea that the work is not about South America or Africa or Europe. It is about the Atlantic. It is the Atlantic. You know? So this is how the work looked at. The paper was burned by the sun, creating this kind of different abstract drawings or prints, one different than the others. And on the back, sorry, I don't have any pictures. They were like, the work was logged. So you could follow longitude and latitude of all the papers. So in a way, when the work was combined, you could actually see the exact route of the paper of the sailor crossing the Atlantic. No, that was it. That's it. I will end now. And if you have questions or comments, I'm of course happy to talk. Thanks a lot.
Thank you very much for your presentation. So it looks like we have some questions. There's one from Stephanie Kate. They They say, I resonate with your concept of materials as exiles themselves when removed from their indigenous landscape. Can reclaimed silver be transformed into new material objects, possibly returned to its place of extraction, or is the metal then chemically distinct from the elemental silver as it appears to be?
Well, thanks for the question. I think it's man, I think it, of course, it can be, I think it transformed already in its movement. Then it's already transformed, I will say, the transformation or the movement makes it different, I would say, Then I think, of course, if you look at colonial history, there is this, many of the places where silver or like other metals and things were taken from are places that now exist in a different way than before. So of course, the taking back, it's a very complicated and delicate question, because who does it belong to? No, I would say no. But I think both, so in a way, yes and no, I would say. Of course, it can be transformed into new materials. But when it's returned to the place of extraction, it is a different material altogether. Because it has traveled and it has become something else. So going back, in that sense, I think there is no going back. It can move, but it cannot go back. Yeah, I don't know if that makes sense for you, Kate, but I think that was a way of answering it.
Stephanie says, much.
Yeah, I know, I read it. I saw it, the comment. Yeah.
For other viewers who might be watching later.
Hmm.
And then there's a comment from Melanie King, who was saying, wondering if you were familiar with the recent exhibition in Gothenburg regarding the migration of objects, considering objects as refugees and the migration of ideas along with people.
I'm familiar with the exhibition. I've read about it, but I haven't seen it. But I think it's not the idea of thinking of objects and the link between I think here, of course, we can open it. As the previous speaker, the idea of objects not as objects, but in some way as subjects, are connected to this this idea of migration. I think that's where something interesting happens. They're not only objects, but they're also forms of subjects and carrying of history. But I haven't seen the exhibition.
Thank you very much, Runo. That was absolutely fascinating. I'm now going to pass over to Oliver. So Oliver Raymond Barker works with the mechanics and alchemy of photography to make images, objects, and structures that expand upon what photography is and can be. Working predominantly with alternative analog techniques, he uses photography as a tool to uncover imagined narratives and unseen processes framed by his interest in culture, ecology, and spirituality. And Oliver has just undertaken a residency at the Exeter Sustainability Institute, and where he's been looking at silver as part of his project. So he will be speaking a little bit about this today. So I'll pass over to Oliver now. And as with all the other presentations, if you have any questions, you can put them in the chat and I'll answer them. I'll ask them to Oliver at the end.
Hey, hi Melanie, thanks for the intro, and yeah, hello all, and it's been great to hear Leah's and Alice's and Runo's presentations. So yeah, thanks for inviting me to talk. So I'm going to sort of do two aspects to this presentation. So I'll share my screen in a minute. The first, I'm actually just going to read a short bit of text from the recent sort of proposal I've made for this pilot project we're working on, just to kind of give some context and background. And there's a lot of crossover with you know, some of the ideas and concepts that have been put forward already, which I think is great. And then I'll sort of just go into a bit of detail about what we've actually been doing. So I'm just going to share my screen. So hopefully everyone can see that. So I won't introduce myself in too much detail because Melanie has already done that, which is brilliant. But this is a quote that I just put in, and I really wanted to share with everyone. This is a book that I was given recently by a friend, and it's been massively inspirational for me, I guess, just in terms of really seeing artists put stuff into practice and that crossover between art and activism and the earth. So yeah, that was a sort of one of the quotes that's really been sort of driving me forwards recently, from Alexis Pauline Gumbs. And then, yeah, I want to talk now about the specific project I've been working on for the last sort of 6 months or so, the origins of silver. So what I'm going to do first is just, as I said, just read a little bit from this proposal that started the project off, and then I'll talk in more detail about what we've been up to. So when we work with photography, we're very often concerned with technical aspects such as the composure, the exposure, development, and how these relate to our overall concept and vision. But how many of us stop to think about the source of the silver that makes some materials? What mine was it extracted from? How was it processed? Who processed it? And under what conditions? What were the impacts on the surrounding land? Our goals tend to take precedence over the questions of provenance above. We acknowledge the importance of sustainability, and yet the making of the art becomes the foremost aspect in our minds. It's true that making art is and always has been a vital part of human existence. However, this relationship between art and its materials has become ever more complex and technologically entwined across history. And nowhere is this conflation of art, resources, and technology more evident than in a field of photography. This contemporary mode of operating, evidenced by our material blindness and disconnection from the source of the everyday products that we use, is deeply problematic. It allows for the flagrant taking of profit from the earth, whilst at the same time distancing us from the land that is being worked. And this extractive behavior plays out across many areas. The degradation of soil through industrial agriculture, the use of our atmosphere as a dumping ground for emissions, and most recently, the zoonotic viruses unleashed by the displacement and destruction of natural habitats. We have allowed higher goals of economic, social, and cultural development to come before the world that sustains us. Though only a small part of this larger problem, it's encouraging that questions relating to sustainability are gaining credence and interest amongst the photographic and artistic community. There has been a great deal of brilliant applied research from individuals and collectives into areas such as silver recovery, alternatives to the use of plastics in film and plant-based processes. However, if we wish to continue with analog photography as we know it, then silver and its necessity is the stumbling block in our backroom experiments. So if we must use silver, then surely we should interrogate its provenance. Where do companies such as Ilford and Kodak source their silver? Can they answer the questions I posed above? And if they can't, then do we need to develop our own alternatives? As a means to explore these questions and others, I'm looking in detail at the area of Cornwall, an area particularly relevant considering its rich mining heritage and potential future, with companies such as Cornish Metals and Cornish Lithium prospecting for new sources of precious metals and rare earth minerals. Along with rich lodes of copper, Cornish Metals have recently found evidence of galena, one of the ores from which silver can be extracted. While there may not be serious economic viability in the extraction of this ore, it does, however, provide an opportunity for us to learn more about the coming into being of silver and its subsequent use in photography. It's a possibility to get our hands dirty, to learn about the magical element upon which we rely, and perhaps this newfound embodied knowledge will inform a way forward in our craft. So there you go. Hopefully that kind of just gives you a context and a very broad background to my thinking about the project. And so, like I said, this is, at the moment, it's just a pilot project that started in sort of March really this year, though it's been some time in the making in my head. And it's a collaboration between myself and some academics from the University of Exeter. So Professor Karen Hudson-Edwards from Camborne School of Mines, and Dr. Eva Marquise, who works with her, and then also Professor Nicola White, who's from the Exeter School of Arts and Humanities. So, and to give you a bit more detail about Karen and Eva and what they work for, you know, the department they work within. So their specific research project at the moment is called Met for Tech, which is essentially a circular economy project. And they're looking on how to improve the supply of raw materials within the UK, also how goods can be manufactured to be reused and recycled. And so there was this really nice kind of research link between what they were doing and the research ideas I had. So it was a clear match, I guess, in terms of a collaboration. Just to give you a bit of sort of extra detail on what they're interested in. So these are their priority metals. So obviously things like cobalt, lithium, the rare earth elements, platinum metals are in there as well. Silver's not listed on there, but that still is one of their priority metals in terms of its use in, a huge range of industrial applications. And then, like Melanie said, I had the opportunity in April to have a short residency at the Exeter Sustainability Institute as part of their creative exchange program. So that gave me some time to start to develop these ideas in more detail, to have some meetings, to sort of think about how I could push this forward. So they gave me a studio space up there for a few weeks, and I worked with the academics I've already mentioned, but also brought in some external collaborators who I will talk about in a minute. Some of them are here today. So in terms of some of the practical ideas I was exploring, one thing I would really like to do, and again, I'll mention this a bit later, is to make some photographic emulsion paper from Cornish silver. So it's that idea of mapping the element right from the start through to the finished product. So often we go and we buy a box of paper off the shelf, or we might buy some liquid emulsion. We have no idea where this silver has been sourced from, like I said, and under what conditions, and what its history, what its journey is. And I love that idea of what Runo was talking of, is that these narratives that the silver holds within it. So then something else I want to investigate is just exploring the idea of limits, specifically within my own practice. So for example, only making work from reclaimed silver. So whether that's, reclaiming from my own archives potentially. Again, so it's very interesting to hear of, Runo's projects, or, going around collecting waste fixative from different darkrooms and using that and nothing else in my practice. The other thing I'm really interested in thinking about is, the potential for some kind of fair trade stamp within analog film and paper production. We think about the timber industry, and there's, you've got the FSC stamp. You think about food, you've got various different standards, organic, soil association, those kind of things. Within the metal industry and the mining industry, there's nothing, often for quite good reasons, in that the mining corporations don't often want traceability. As we know, it's a dirty industry with a very checkered history. But I think working with these academics, that is something they are committed to trying to get big industry to change. And so looking at that kind of aspect of it in a very small way. So for example, trying to work with a company like Ilford or another film company, and a silver recovery unit like JBR, who are based in the Midlands, and running a pilot project with them. And then the other aspect, which is very important to me, is then actually collaborating with the local community of Cornwall that have been affected by mining, whether that's in the past, the present, or this potential future that is occurring now because of this this new prospecting. And that could take the form of events and talks or workshops with the community, maybe even some form of action and activism, if that's needed. So very briefly as well, just talk about those external collaborators that I brought in on the residency. I won't talk about Alice's work because we have just heard her presentation, and Melanie's work as well. So Melanie was involved with this this residency at the Sustainability Institute. So Ed Carr, who is one of the co-founders of the Northern Sustainable Darkroom, along with Alice, wrote a brilliant essay on speculative futures for photography, and the use of silver within the independent film lab sort of industry. So that's a fascinating new piece of writing that he developed as part of the residency. William Arnold was exploring connections between satellite imagery of silver mine locations and darkroom processes. So he was taking screenshots of different silver mining sites around the world and then converting those into darkroom negatives and making these beautiful lithe prints out of those digitized images. And then lastly, Guy Martin, who was actually working with lithium as opposed to silver, but his work still felt very relevant to the current Cornish exploration of resources. So it was great to bring in 4 or 5 different artists and collaborators on this project at an early stage, just to get different perspectives, I guess, different voices into the mix, and to also help the academics to, I guess, gain an understanding of what kind of works were out there and what was happening in the field of photography in relation to silver and resource usage. So then I wanted to speak in a bit of detail about this site visit we did about a week ago now. It's to a place called Coombe Martin, which is a silver mine in North Devon. And it was worked for about a 700-year period from the 1290s. I mean, that's the earliest recorded workings. It probably goes way, way back before that, as do many mining sites, obviously, around the world. And it stopped really being mined in the late 1700s, and had a very complex history of opening and closing, as many mines do, because of civil war, the Great Plague, importing of metals from the colonies, changes of ownership. So it's got an amazing history, this mine. And yeah, like I said, the 1790s was when it was last active, and I think about 9,000 tons of silver ore sent to South Wales to be processed then. And it was actually a very rich mine, even though it's relatively small. The ore grade was pretty high. It was an average of 14% silver bearing ore. So I went to this mine with myself and a couple of academics, and we were given an amazing tour by Gary, one of the old trustees who's developed the kind of museum, if you like, over the last 20 years. And they've got quite a good range of samples there still, which we are hoping to work with in the coming months to actually refine some silver, probably through chemical leaching rather than smelting. I'd quite like to try smelting, but obviously it's quite dangerous in terms of health and safety. So we went deep down into this mine. I think we went down to the 46th level, so it's quite a long way down. And it was interesting, it was different areas worked at different periods. So we started off higher up in what were the medieval workings, and then gradually went down to the deeper workings, which the Victorians had developed. This just shows you one of the deeper levels that we were going down to. And these are the 2 academics, Eva and Karen, that I'm currently working with. This is one of the stimming rods. So this is one of the rods that would have been used by the miners to place the explosive charges. And this is just a UV photo showing some of the minerals. And this is the journey back up. So it was a fantastic insight into the mines of that period, and it's a very rare opportunity to go down one which is in a way so untouched. I mean, the health and safety is non-existent really compared to a lot of other mine sites you go to. So it was a great insight historically. So in terms of then thinking about the future of what we're looking to work on, some of the key research questions is, what is the future of mining in Cornwall? And how might Cornish mining be part of the circular economy that Met4Tech are looking to develop? And also, how might that link in then with the speculative futures of photography that I'm thinking about? And what will the impacts be on the Cornish landscape, so ecologically, but then, what will the social, cultural and commercial impacts be? And I guess what I'm really interested in is how photography might illuminate these themes, but also how can it activate a positive approach to our resource usage in the future? And obviously, in terms of outputs, you know, we're thinking of writing an AHRC funding bid soon, and there could be various collaborations, whether that's artistic and academic, but also hopefully community and industry, and then talks, exhibitions, publications, and interactive platforms. One of the key ideas, I guess, I'm really excited about, and so the other people I'm collaborating with, is this idea of bridging organizations. So the possibility to work with someone like Ilford and Cornish Metals, JBR Recovery based up in the Midlands, and you know, someone like the Independent Precious Metals Authority and the Sustainable Darkroom, to look at, I guess, you know, sourcing and traceability within the photographic industry. And then something I just wanted to finish on was a quote by Janine Benyus from her book Biomimicry. This has been massively influential to all the work I've been making for the last 4 or 5 years, and really taps into that idea of limits. So nature runs on sunlight. Nature uses only the energy it needs. Nature fits form to function. Nature recycles everything. Nature rewards cooperation. Nature banks on diversity. And I think there's a bit missing actually from the end, which is nature taps the power of limits. So I'm going to stop sharing now. So there you go. That's just a kind of whistle-stop tour of what's been happening over the last few months. And yeah, exciting to see how it might develop over the next year or so.
Thank you very much, Oliver. So we have a question from Stephanie. Says, thanks for sharing your deep dive into mining and local alternatives for sourcing. It was interesting to think about material blindness with such a strongly visual media. In your research and experimentation, what alternative extraction reclamation techniques do you see as being most productive or scalable for continuing photographic darkroom practices as they are?
Great, thank you, Stephanie. Yeah, it's a good question. I guess it depends at what scale you're looking at, doesn't it? I mean, I can sort of, you know, I work at the university, so I can look at, they already have a silver sort of reclamation facility there, but they're open to the fact that I could use it instead of the silver reclamation company. So I could go around collecting fixative, you know, waste paper offcuts from all the local darkrooms, and that could be a very small scale kind of reclamation. I guess what would be interesting is with this collaboration with industry is, you know, are there much larger scale, you know, possibilities out there? So in terms of, you know, there's not a huge amount of silver ore left at a site like Combe Martin. So something like that's probably not an economic viability, but when you're looking at the new possibilities for mining down in Cornwall, which are serious actually, you know, at scale operations, and if they continue to find more silver bearing ore, you know, silver is often a byproduct of mining, as many of you know. It's not generally something that you would always go and look for first. You might be looking for copper or tin or rare earth metals, and along the way you find some silver. But I think what's quite exciting is that, yeah, with the serious scale exploration that's happening in Cornwall, then that could actually lead to a reasonable amount of silver reclamation and, well, extraction from ore happening at source. Yeah, so hopefully that kind of answers your question, Stephanie.
Stephanie says, thank you. I'm interested to hear more about what goes on in Cornwall. So thank you, Oliver. That was fascinating. It was great to see your photographs going into the mine. Interesting new development in your work. So we're going to have a break now. So it's going to be about a 27-minute break. So we'll be back at 3 p.m. UK time.
Thank you very much, Melanie, and thanks for giving me the opportunity to tell you about silver today, or about my studies of silver. I would just like to start by sharing the slides right away. I hope you can see them.
Yes, we can see them.
Perfect. So I will talk about silver and palladium, two of the elements that I've been working on during my PhD, but continue to work on now even today. And I am a stellar spectroscopist, so I will talk about how we can observe them in stars. But in order to observe them in stars, we also need to have them formed in the cosmos. And here I will also tell you a little bit about how they're actually formed through nuclear reactions. And as we all know, the periodic table has a large number of elements, and the vast majority of these we can actually observe in stars. We refer to most of these elements, basically everything that is heavier than hydrogen and helium, as metals. And some of these metals are more precious than others, and I will show you today why that is from a astrophysical point of view. So if we start with how do we actually form the elements in the universe, well, then I will rush through in a fast way and show you how they actually start from the Big Bang. And after the Big Bang, we have a very ionized gas or soup of elementary particles, and only once this cools, we actually get neutral hydrogen. So within or after about 15 minutes after the Big Bang, the universe consists mainly of hydrogen, helium, and very small amounts of lithium. And actually only after 400 million years, the first stars condense and start to exist. And only with these first stars, we get elements that are heavier than lithium. During these 400 million years, there's absolute darkness. And since these stars were very massive, they explode as supernovae. And during the lifetime of these massive stars, they can form up until iron or nickel. But in the explosions themselves, a lot of even heavier elements can be formed. And we now know that also there are other ways of forming heavy elements like silver and gold, namely through the mergers that were detected through gravitational waves in 2017. And here, the basic concept is that two neutron stars rotate and spiral in, and they merge. And in this merger event, a very extreme explosion also takes place, and here the heavy elements can be formed. And then later on, a mixture of massive and small stars will take place. We start seeing that we get more and more stars in our galaxy, and we also get more and more heavy elements, as you can see here on the right-hand side. And not all stars can make the same elements. Some low-mass stars will make, or intermediate mass stars will make elements like lead, whereas other stars will make elements like gold and silver. And then about 9 billion years after the Big Bang, we have the sun and the earth. And we are at the point where we have a fully populated periodic table. So this is just a breakdown. We see that after the Big Bang, we have mainly hydrogen, but also helium and little lithium. As time passes, the massive stars will form up until iron, possibly nickel, and they will, in the explosion, eject large amounts of carbon, nitrogen, oxygen, and also magnesium. And as even more time passes, we will have the explosions of supernovae, but we also have the merger events, and here we can form elements like silver. And then it's actually a cosmic recycling that takes place, because the gas that is ejected from these explosive events will then be sent back into the galaxy, will cool down, and a new generation of stars can form. And this is where the stars actually also record what has taken place beforehand, just like the Earth can record what is going on with the precious metals. So this recycling is very important to our understanding on how the chemical composition of the galaxy is enriched as a function of time. Now, I mentioned that the stars during their actual stellar life, but before they explode, can form up until iron. And the reason for this is what you see here in the diagram. So as elements are fused to heavier and heavier and heavier, binding energy is one. And this is exactly the energy that is radiated away from the star. This is why the sun is radiating. And you see that the maximum energy is one just around iron. And this energy is basically because you keep increasing the mass. So you have Einstein's E equals mc squared. And this energy is the radiation that we now see. And you see that the maximum is reached around iron, which means that if we wanted to pursue this sort of fusion process, the process would be endothermic and it would cost the star energy, and it can't. And this is why, as a struggle to keep surviving, the star then starts contracting, which then actually results in the explosion eventually. And during these explosions, we have fission processes, and these fission processes release a lot of particles, such as both protons and neutrons. Now, the thing is that since an iron nuclei has a lot of protons, it will repel further protons that try to be captured onto the iron nuclei in order to make it heavier. And this is why almost all elements that are heavier than iron and nickel will be formed via neutron captures. So silver, as well as palladium, gold, uranium, are all formed via neutron captures. And this is a little bit of a busy, messy diagram, but it basically shows all the various isotopes that can be created in various nuclear reactions. And on the x-axis, we have the number of neutrons, and on the y-axis, the number of protons. What we tend to observe and measure and have on Earth are the stable ones, which are the little black points. But we can get to these black points in different kinds of ways, and we can also get through them via different astrophysical objects. There's also a large number of elements and also isotopes and reactions that we still don't know to date, because they're extremely neutron rich, which make them very difficult to measure in the lab. But we now know that up until lithium, these elements were mainly made in the Big Bang. Up until iron could be formed in massive stars before the explosion. We can form elements such as, for instance, lead in intermediate mass stars that are unstable and pulsate. And we can form gold and uranium, silver, palladium via explosions such as from supernovae or from these neutron star mergers. And these will take place in a so-called rapid neutron capture process. And right here, just at the border of the unexplored territory, we have silver sitting. So the idea is basically that you form an element like silver or palladium by capturing a neutron, and then it beta decays to become stable, and thereby converting the neutron into a proton. And if you are in a very explosive environment where you have a lot of neutrons, such as neutron star mergers, they're full of neutrons, you will consecutively capture many neutrons before it will manage to decay. And this is what pushes the isotopes far away from stability. As I mentioned, you can form many different kinds of elements, and supernovae were definitely the first in the universe to create heavier elements. In these explosions, we get a lot of energy, but also a lot of particles ejected, and these now enter into the following reactions that can form heavy elements. We can also use a tracer of the supernova, namely that we know that supernova form a lot of carbon, magnesium, and calcium. And if we then combine and also see that we detect silver, then we definitely know that this supernova was a special kind that hosted this rapid neutron capture process that is one of the that is a way to form elements like silver. And these massive stars tend to explode once they exceed 8 times the mass of the sun. I also mentioned that we have mergers, and these mergers were detected for a while now, but it was only in 2017 that we actually got a spectrum and could determine the chemistry of these neutron star mergers. And these neutron star mergers will also occur a little bit after, so a delayed with respect to the Big Bang compared to supernovae, because they require that we have two supernovae exploding, leaving behind two neutron stars that can then eventually be gravitationally attracted to each other, spiral in, and explode. And here the fascinating thing is that once the neutron stars that you see depicted in this model, the two blue clumps of the neutron stars, once they get close enough to really spiral in and merge, the merger happens within 10 milliseconds. This is faster than you sneeze, and the heavy elements form within milliseconds. So this is a very strong, very energetic process that forms silver, europium, uranium extremely efficiently once it occurs. The only thing is that these sort of mergers are predicted to happen once every 1,000 years in a galaxy, whereas the supernova can happen once or twice per 100 years. Now, my approach has been as an observer to observe old stars that sort of lock up the composition of what has been going on before they were formed. And this is now where we turn to the night sky. If you look carefully, you might recognize the Big Dipper. And if we want to understand something about the formation of silver, then we tend to look far away towards old low mass stars, because these are the best labs for our understanding of nucleosynthesis of silver and palladium, for instance. So this is where we now select a region that seemingly seems empty, but thanks to large telescopes with very extremely and efficient spectrographs, we can, after hours of exposure time, see that there are actually stars far away, and we can get their chemical composition through detailed spectroscopy. Now, this is where the Very Large Telescope in Chile is fantastic. There are, as you can see here, 4 domes containing an 8-meter telescope, each one of them. And you see here that you are in the desert, so there's absolutely no light pollution that will interfere with your observations. And you can also see here that you're in the mountains. It looks like this is the sea, but this is actually the clouds seen from above, because we are up high. And what we then use, we use one of these where we have an extremely efficient spectrograph, and we observe the spectra of the stars. Now, this stellar analysis was discovered already in the 1860s, where Bunsen and Kirchhoff had little prisms standing, and they saw that the light would come in, get dispersed, and you would see these little rainbow patterns. Now, what we use is that within these rainbows, you actually see black regions which correspond to absorption lines. And analyzing these absorption lines, we can learn a great deal about the chemical composition of the star at a given time. And this can then be broken down to be snapshots of how the galaxy was enriched throughout time. If we want to observe silver and gold, we need to look into the ultraviolet, and gold can actually only be observed in the, say, far away, far ultraviolet, and therefore we cannot observe gold from the Earth, but only from space. The general idea behind such stellar observations and this spectrum analysis is that the larger our line is, the more we have of a given element. So if we would see a small stellar absorption line, we would have little gold or silver. And if the line would be large, then we would have a lot of this element. And this is how we break down the composition of the star. Now I mentioned that we would observe old stars, and the reason for that is that they are chemically simpler, so it's easier to understand the actual nuclear processes that took place and enriched them. However, as you can see, there's a wealth of stars out there, and we need to find a way to detect these old stars and observe them in larger detail. And the way we do this is we select some calcium lines. If these are weak, then we can go to Chile and observe and get the detailed information. And you see here the sun, which is about 5 billion years old. You see a lot of strong lines, you see magnesium and so on. And if we were to look at silver, we would have to look way further into the blue or ultraviolet. However, you also see the effect of the age of the star. Here we're looking at stars that are 10, 12, maybe even 13 billion years old, and you start seeing how the lines weaken. And this is a direct indication that we are now looking far back in time and far deep into space. For silver particularly, we are forced to look at regions in the near ultraviolet. And you can see this is 10 nanometers in the ultraviolet compared to 10 nanometers in the visual. It is much cleaner to look in the visual. But if we want to learn about the heavy elements, we are forced to look at the ultraviolet region. And right in this very busy region, where I would like to note that everything we see here is a line. It's not noise, it's stellar lines that blend together. And these spectra are some of the best spectra we can get. These have been observed with the very large telescope in Chile. And now if we zoom in and we do a detailed modeling, we will actually see that right here around 328 nanometers or 3,280 angstrom, we have silver line. And silver is a blended compound. So we need to separate what belongs to silver, what belongs to zirconium, and what belongs to iron. And then we can get the abundance of silver. And this was exactly what I did for my PhD and whatever every stellar spectroscopist is doing in order to understand the chemical composition of the star. Now, why would we care about silver? Why study silver? Well, it was predicted by theory before this study to be formed by the R process. But if we compared it to other elements where we know the formation, we see that something wasn't right. We compared silver to europium, where europium was our best R process tracer. And if these two elements were indeed formed in exactly the same way, then element A and B would show a classical correlation in the sense that they would grow and correlate in the same way. However, if A and B are not formed in the same way, where B would grow much faster, for instance, because of a different tendency in the nuclear synthesis, then you would see a flat or a decreasing trend. And this was actually exactly what we saw, this decreasing trend, which was a big surprise because we thought that it was all settled, it was formed by the R process. And this was actually what led to what Melanie mentioned, the National Geographic paper, because there seems to be another way, another kind of R process that forms elements like silver and palladium. And then I would shortly touch on why silver is a precious metal. You see here relative abundance versus all the different elements. And you see that hydrogen, we have a large number of, we know that already from the initial slides. And we would, in 1 million hydrogen atoms, have less than one silver atom. We would basically need more than 10 billion hydrogen atoms to get one silver atom in space. And with this, I'm reaching the end. I'm showing you now that we need all stars, we need spectroscopy of all stars to understand the chemical composition of our stars as well as our galaxy. And we tend to observe these with the large telescope in Chile so that we can get the best spectroscopic information. And when we do that, we can get information about thorium, europium, silver. Based on these, we can compute the ages and we can compare our elements to, for instance, predictions and learn more about the theory as well as the astrophysical objects that form these. And what I want to really highlight is that by observing all stars, we are now understanding how elements are created more than 13 billion years ago. And these elements got locked up in the stars where they survived, and they nowadays tell us about the nuclear processes that happened just shortly after the Big Bang, possibly even in the first stars. And with this, I want to thank you for your attention.
Thank you very much. We have a question from Stephanie, who said, thank you very much for sharing your work with us. Wonderful content. Could iron be considered a relatively sustainable metal to use for photographic light reactions compared with elements produced through more delayed cosmic processes, such as silver, platinum, or palladium?
I have to say, I don't know enough about the chemical properties of iron. I don't know if it has the same sensitivity to, for instance, light as you would probably need in silver. I could think that there would be other elements that would be useful, but I don't know if they would be lighter and more sustainable elements.
So I think that's something that I'll cover in my presentation.
Perfect.
Yeah, that's something that I will talk about and is part of the exhibition at Photofusion. I don't think we have any other questions, so thank you very much, Camilla. That was absolutely fascinating and interesting to think that silver is precious in space as much as it is on Earth.
Definitely. Thank you very much, Melanie.
Thank you. So now we're going to hear from Ignacio Acosta, and he can't be with us today either. So I'm going to introduce his work and then I'm going to play his video. So Ignacio invites a viewer on a journey of copper from raw material through stock market exchange value, smelted commodity, capital wealth, and recycled material. From the transformed landscapes of the Atacama Desert through a reimagined voyage to Wales and the city of London, the project documents spaces of circulation, environmental disruption, protest, and trade, and makes visible the return of the copper hidden within technological devices to its geographical origins. Ignacio is a Chilean-born, London-based artist and researcher working in places made vulnerable through the exploitation of ecologies by colonial intervention and intensive capitalization. He works with the interconnected research projects that involve extensive fieldwork, investigative analysis, audiovisual documentation, and critical writing on sites and materials of symbolic significance. He focuses upon resistance to extractivist industrial impact on valuable natural environments, and through technologies of seeing, develops work towards generation of meaningful visual and spatial narratives. His interventions position geological and technological forms, as well as human and non-human relationships in the same landscape. Situated within the urgent need for artistic approaches to critically address the depleting landscapes created by mining, his work creatively negotiates the complex buried within our living world. So I'll just share my screen and you will be able to see his presentation, which is about 25 minutes long. Let me know if you can't see or hear.
Hi, Melanie. Thank you so much for inviting me today. I'm really sorry I cannot be with you. So I just, it's a really, with you all my work, I mean, in relation to your exhibition. What I will share with you today is my work, Copper Geographies, and in generally talk a little bit about my experience working with different minerals and particularly with copper, which is my work that I developed as part of my PhD at the University of Brighton, that was developed as part of the research group Traces of Nitrate. So I will share with you all a presentation I have. This is here. So, so my work on copper began in 2010 as part of my involvement with the research group Traces of Nitrate, as I said. So my name is Ignacio Acosta. I am a researcher and an artist exploring places vulnerable through the exploitation of colonial intervention and intense capitalization. Over the last 10 years, I've devoted myself to the understanding of places that, although seems marginal, are significant for the global economy and the global environmental disruption that is going on at the moment. These places are often neglected, but as I said, of very significant importance. My most recent work explores the role of drone technologies as a resistant and the colonial tool for mapping the impact of mining industries. But what I'll share today with you is mainly all my work related to copper. My work, as I think it's important to understand, that is developed through different collaborations with activists, indigenous peoples, historians, and writers. And it's the basis for this collaboration that is forms the projects that I work on. So this is our project, Traces of Nitrate. We are currently working on a larger project about the impact of copper and lithium mining on the glacier ecologies of Chile and its relation to the UK. So we also work with how these places of extraction, places in Chile, these remote places are linked to site of extraction and disruption in the UK. This is one of the pieces we have developed. It's called Traffic in the Earth, of El Tráfico de la Tierra, which was exhibited at the Museo de Contemporary Art in Santiago. My work formed as a book. This is called Copper Geographies, and this project links the British investment in Chile copper mines, and then how that is affecting the environment and the social fabric of Chile. So the project, what it does is a kind of sort of forensic investigation into different sites and landscape of significance that connect these geographies. For example, this is a rock, a copper rock, that is found at the Liverpool World Museum. My work developed through research that involves like writing and into the kind of historical significance of the industry. For example, I have written extensively about copper and the role of copper as a metal in worldwide communication technologies. But I became really interested in copper as a way of understanding how this material is also hidden between cables and behind walls, and then kind of trying to map or trying to understand how can we make visible the impact of these invisible networks of exchange and productions across the globe in the geographies where the copper originates from, which is in this case the geography of Chile. So the project works mostly as in a form of mapping. So mapping from the rocks of for example, this rock that I found at the École des Mines in Paris. It's a natural rock, and how the copper is transformed into different forms, technological forms, but also what kind of trying to understand how this material leaves a trace on the landscape. This is, for example, a site called Chuquicamata in the northern Chile. It was a model town created by the Guggenheim brothers in the 1920s. And after that, it has gone through a series of political processes in which copper was nationalized and these industries were transformed. But also I've become very interested in how copper is also part of the environmental fabric of the country, but also form kind of series of political disputes in the country. I don't know if you might know, or some of you might know, Chile has the largest reserve of copper in the world. They are mainly found here in the Atacama Desert. This material has a very large impact on water resources of the country, especially it has a lot of, there's a series of disputes between agricultural and indigenous communities that are fighting for the water resources. In this case, for example, we see a water pipe that goes through the Atacama Desert and carries water. That is one of the basic elements for the production of copper. I've been also very interested in understanding how copper is kept in different forms. For example, in the London Natural History Museum as a scientific specimen, but also how which sites in Chile has been used to exploit the resource. Like this is a mine that was also set up by the Guggenheim brothers, but then exchanged different form in different hands, and now is part of the mining corporation called Codelco. So I developed different types, different bodies of work around the copper. I don't know if I've said that, but I developed this project between 2010 and 2016. My book was published in 2018. And I was very interested in, for example, this kind of mining, advertising mining for the mining industry that I found in the outskirts of the city of Calama. So I developed this kind of series of posters that gives the viewer kind of an insight of how the mine works, but without actually showing the mine. This is the mining town of Calama, so the Chuquicamata mine, and then is developed as a very topographical, large format photographs of this mining town, and kind of trying to understand little by little how this is also being dismantled. Because today the mine has expanded, and then this lag heap is slightly burying what it was, the town, so burying and this all being kind of sucked into this huge residues of waste material. As a result of copper production, there are cities like, for example, in Iquique, where with the large copper mine in the world exists at the moment, which is called Escondida, and Escondida, which is called the hidden mine, has transformed the environmental and then the fabric of the city. There's some housing developments that are also tied to the boom and bust of minerals. So, for example, when China stops buying copper, the construction is also slows down. One site that has been very particularly important to me is this site in the north of Chile, like in the halfway through towards the desert, is a mine called Los Pelambres, managed by a corporation, very large mining corporation called Antofagasta PLC that trades in the London Stock Exchange. This is the Tailings Pond, which is viewed here from Google Earth. We sometimes don't know how it's real, because we know that Google might show this smaller than actually it is. this is in a very prone earthquake zone. So if the mine would collapse, it would also probably break and then kind of buried a whole town, which is called Caimanes. And this city of Caimanes has been at the center of dispute between environmentalists who are fighting for water scarce resources and water contamination. What we see now is like a photograph of a landscape. This landscape might look like as a very beautiful landscape of the north of Chile, but if you look beyond, there's a line, and in this line, behind this line, is this toxic mining residues of called El Mauro, which is managed by this very large corporation. And then also not just the residues that stay in the tailings dam, but for example, this eucalyptus forest trees that it was planted by Antofagasta Minerals to release all the toxic residues from the. So in this case, for example, the copper would be produced in the Andes Mountains, and then through a very big pipe, they take the copper as a grounded material in a form of concentrate, what is called. So it's a black powder that is grinded with water. This water is then transported to the Pacific Ocean by pipe, and then all this excess of water is being used. That is highly contaminated water is used to water these eucalyptus trees, and then I like to think this as a toxic forest because there's a very toxic eucalyptus trees that is a foreign introduced species that is actually produced to increase the profitability of the industry. I have exhibited this forest in different forms, like a poster by this is in the Museo the Contemporary Art of Santiago, and always goes together with this photograph of a protest that is a group of environmentalists that are fighting for the water scarcity and protesting against the mining company in London. For example, this was exhibited at the exhibition Tales from the Crust at Catalyst as a large window poster, but also always accompanied by documents. These documents are also telling the story of the fight of the environmentalists and how they have been impacted by this mine. So this project also makes a kind of understanding or reflection how the material returns to the place of origin, but before returning as a form of technology or even recycled technology, it travels to the other side of the world. So it would go sometimes in this form of concentrate, as you see here in the port of the Puerto Chungo, which is a port that shipped this copper concentrated to places like China or Bulgaria, where it's smelted. Then my project kind of does this sort of metaphorical reflection on the trouble of the material and how this arrives to places like in Swansea Valley in the 19th century, where copper was then transformed and then into form of into commodity. There's some places in Liverpool, for example, where this the copper is stored before the copper is delivered to the final consumer. Is traded in the London metal exchange up to 10 times. So it's exchanging hands, through this kind of contract, which is called future contract. So it's all about setting up a delivery time of copper in the future. And between that delivery time is possible for traders to exchange hands of this material. Then I did this understanding of how copper is also transformed through high technological industries in the Lower Swansea, in Wales, as a couple cables. And I did this kind of small photographic series in this copper technological industry that transformed Chilean copper in, for example, these fans that are used for computer generators that are like cooling systems, that this particular made in South Korea. So it's all about, my project has always been about kind of the understanding of this global phenomenon and how there is possible to actually map and to trace this large abstract processes through photographic and research processes. Then you might be aware that London, for example, is one of the centers of global trading metals through, as I said, the London Metal Exchange. So I worked also in this mapping of industries. This is a mapping of companies trading with the London Metal Exchange in the City of London. And then also created this kind of map of these companies, how they looked on Google Earth. This is the trading ring of the London Metal Exchange, where the global price of copper is set. And this is more or less how the project is exhibited in an exhibition space. This is I showed probably recently before this image of the group of London Mining Network. London Mining Network is an association, an activist association based in London that buys shares of the companies. In this case, they bought one share of Antofagasta PLC, which gives them access to the stockholders meetings, where they can raise their concerns about the contamination and then pollution of water in the environment and in the communities. This is another protest about Zambia, and I've been always interested in this kind of relationships and understanding of the icons between protests. Like, for example, we have the billboards, the protesters, but also the Mercedes as a symbol of corporate power, and London as a center of global metal exchange, and also a center of resistance of the communities fighting against the exploitation of their resources. Then I kind of create an understanding and a reflection on how the copper returns to the places of origin, in this case, Chile. This is the large observatory of the ESO, of the Paranal Observatory, which is one of the biggest observatories in the world to observe the stars and then the constellations, and then which of course uses copper as a central element in their mechanism, but also how the material returns back to the place of origin as form of recycled technology. In this case, this is a company called I forgot the name. I will get back to you with the name, but this company, what they do is they recycle technology and they send back to Chile and to developing countries computers and technology and in the form of, and then copper goes within it as a form of recycled technology. But this, then this is, sorry, I think there was a problem of a glitch on the previous image. This is an image of, which is something I've mentioned before. I've been very interested in how drone technology is used in mineral and mining industries in order to enhance in order to improve the quality of the facilities on the ground. This PIX 4D is a photogrammetry perspective mining technology that is used by the mining industry to improve the qualities of the ground. And recently, I have been using like drone technologies to map what is happening on the ground, but from above, an aerial view. This is an image on my project, Drone and Drones. It's a project that I developed for the Hasselblad Foundation in a project called Drone Vision. And then I work with activists fighting against a mining industry called Galak in the northern Sweden, and then trying to think of using this technology as a content surveillance tool, and also most recently also trying to use the technology as a way of mapping and then creating 3D models of predictions on how industries will change the landscape. I think I'm really aware of the complexities and then problematics of using technology that uses minerals within the technology, like in these computers that I'm recording this talk, and then through which we are able to communicate, and it's something that is coming up as an important issue to try and understand how can we develop a more sustainable approach to our practices, but also acknowledging the significance of the possibilities as it gives us in order to communicate these issues. And this is a contradiction that I hope it can be raised in your discussion. And this is, for example, how the project has been exhibited, and I can probably share with you some of the links to this film, so if anyone wants to watch a little bit more on this project. For example, this is a way for me to kind of map the industries and using 3D technologies, using photogrammetry perspective. Yeah, I would like to thank you very much all for listening. Thank you so much. I'm really sorry I cannot be with you. I'm going to be taking a bit of summer holidays, but I wish you a very joyful and then productive discussion. And thank you so much for inviting me and for allowing me the space to share with you. And then, yeah, thank you very much. And hope I'll see you soon. And I look forward to hear the discussions, right? Bye-bye, thank you.
Oh, that was incredibly thought-provoking. Thank you, Ignacio. So now we're going to hear from Charlotte Padgett. So Charlotte is an experimental and sustainable artist and jewelry design maker, exploring themes of transition, manipulation, ephemerality and imperfection using found objects, waste material and organic matter fused with precious and semi-precious elements. She has a fascination with texture, degradation and decay, and in the traces and residues left behind, often using her body as a tool and material to explore the transference, intervention, and preservation of the self. Circular economy principles are an integral part of her process, with a focus and commitment to ethical and sustainable making. Materials and waste are reused, reworked, and recycled within and across her art and jewelry practices, She is passionate about sourcing materials with her own hands, reusing what is already in circulation, and giving new life to what cannot be recycled. She is a member of the Society of British Jewellers, the Guild of Jewellery Designers, the Association for Contemporary Jewellery, and Precious Collective. She is also included in the Crafts Council directory and was amongst the first 50 jewellers to have taken the Fair Luxury Pledge in 2021. So I'll now pass over to Charlotte.
Hello there. I'm going to try and share my screen. Hopefully that works. She says. So I've got cold hands. My computer's not responding. Does that look like it's working?
Yes.
Brilliant. So thank you so much, Melanie, for bringing me on board. And it's just been absolutely fascinating listening to everyone today. I'm looking forward to the recording to listen to it all back again, actually. There's so many ideas and perspectives. It's really inspiring. So thank you. And also thank you for that amazing introduction. That's kind of halved my presentation time, maybe. So I'm just going to talk a little bit about my use of recycled and responsibly sourced metals in my jewellery and artworks, with a few examples of the processes I use for reducing and reusing waste within my circular studio practice, which includes my work on silver reclamation from used photographic fixer. So starting points in my work tend to lie in found objects, waste materials and organic matter, including myself. So my skin and my hair feature heavily throughout my photography, artwork and jewellery, using my body as a tool and material to explore ideas around transference, intervention and preservation of the self. So I'm just going to show you a few images of what I do. So the methods I use to create these pieces in silver leaves a direct imprint of my skin and my hair on the surface. It's a hairwork ring using traditional Victorian hairwork techniques, which is known as, this particular technique is called gimp work. I'm not entirely sure why it's called gimp work, but and to create jewellery directly with my hair as a material. Some photographic images using photographic emulsion on recycled papers. The images at the bottom were actually made through physical contact of myself on the glass. Don't try that at home. And then using fingerprint dusting powder to reveal the skin cells and oils left on what look like, to me, slides. This is from my relic series, a series of photo etched artworks of my hair on copper, and then remnant series, which is a series of intaglio and relief prints made from the etchings. I have a series of paintings called sympathetic resonance, using brushes that are made from my hair. So circular economy principles, as Melanie mentioned there, are at the heart of what I do. I focus on reusing, reworking, repurposing and recycling as many materials as possible within and across my art and jewellery practices by incorporating remnants, waste, or certain elements or concepts from one piece of work to develop and construct a new one. I'm interested in reactions, manipulation, intervention between found and waste materials and traditional materials and techniques, with an overriding view to ensure as little waste as possible leaves my studio. This does, of course, mean I have quite an eclectic collection of stuff hanging around my studio, but it's important to me that everything within my studio has a purpose. It forces me to make my materials, equipment and designs work harder and more efficiently, especially where metals are concerned. So in the jewellery industry, there are three widely accepted options for responsibly sourced precious metals. So that's fair trade, fair mined, and 100% recycled. Historically, jewellers and metalsmiths have always recycled and reused materials, mainly due to costs, especially when using precious metals. So it makes economic sense to be resourceful, but it's becoming much more of a focus now in terms of provenance of materials and what we do in order to for our work to be more ethical. The general public now have a much greater awareness thanks to better education about supply chains and the impact at source. And so there's a lot more pressure than ever before from consumers, and rightfully so, for transparency and accountability. And with jewellers also increasing the pressure on suppliers, it has led to more ethical options being offered and being more accessible. Plus, as of very recently, actually, in some cases, recycled precious metals have now become the standard. So all the metals that I use within my practice are recycled and reclaimed. It's important to me, and it's part of my process to reuse what's already in circulation. And that includes base metals, pewter, lead-free, copper and brass. And also reusing what I find, you know, living in a locality where sometimes cars get burnt out. So, you know, I'm like a magpie, I pick these things up and reuse them in any way I can, making some kind of positive, hopefully, out of a negative. So this includes not only purchasing from suppliers that offer, it also includes, purchasing from suppliers that offer certified and fully traceable recycled post-consumer precious metals, which was up until fairly recently branded eco silver and eco gold by one particular supplier, and is made up of precious metal that's already in circulation. So it's recovered from industrial use, i.e. electrical parts and plating, medical and dentistry, scrap silver and giftware. Although interestingly enough, I did a bit of digging and not from the photography industry, which apparently the processes in reclaiming the silver on that scale don't make it viable, but I beg to differ. So any waste materials produced, but whatever I make, is retained and recycled myself. Any scrap pieces and filings are melt or fused to directly create new pieces or surface textures, or poured into ingot molds and hammered and rolled into sheets and wire as required. Scraps and accumulated silver dust can also be collected up and offered off, sent off to refiners for refining. So bench sweeps, I think you can just about see there's a bunch of sandpaper, Hoover dust, dredge from tumblers and ultrasonic cleaners. But since refining requires quite a lot of energy, amongst other things, I personally want to reuse and recycle as much as I can within my own studio first, and only send off once I've accumulated a decent amount. So I meticulously sweep up filings to reduce contamination so they can be reused within my studio. And I have designated brushes and jars for each metal. So this is an infographic from Pressman Master Melt, which is a refiner. So they offer a very comprehensive guideline and an accredited service, although I should say other refiners are also available. As you can see, they can pretty much process everything in the workshop. And this is something they really advocate, so as much metal can be, well, a lot of metal can be unwittingly wasted. This stringent reclamation goes for all metal and material generally, offcuts and filings within my studio. I collect everything, which includes any paper, plastics, waxes to reuse in some way. And that also includes making tools out of old rotary drill bits, old nails, bits of steel and brass rod to make stone setting tools or jigs for shaping wire, using old metal hammers for texturing or repolishing them so nothing gets wasted. So generally speaking, I try to extend the lifespan of everything within my studio so everything has multiple uses. However, as much as I am a massive advocate for reuse to minimise the impact of my work that it has on the environment and those in the supply chain, I'm also extremely aware that I'm actually in a position to be able to support the livelihoods of small-scale artisanal mining communities who completely depend on their industry. So last year, I became a registered fair trade goldsmith, so that introducing fair trade gold into my work means I can actively promote and influence the demand for safe, responsible working practices, ensure that the communities and environment are supported, and establish an essential human connection to the supply chain. But as it happens, the sad truth is right now is that I can only use gold if a piece is specifically commissioned, as I just can't afford to buy it. But it's important to know that what gold I do use has certain provenance. Having these systems in place, whilst by no means perfect in the grand scheme of things, helps to at least contribute to a more resource efficient and environmentally conscious practice. But I am continually reassessing how I use the resources that I have. Part of my process is seeing how far I can push and extend the life of what I have around me. But it also helps me to think ahead and take responsibility for addressing any consequential waste and incorporate it as part of the design process. This means that if I make something, any waste stays in my studio until I reuse or recycle it. It's actually a really good deterrent. If I can't incorporate it or recycle it, I either rethink how to make it more efficiently next time around or not at all, which I think might bring me nicely to my photographic reclamation work. So back in April 2020, I was invited to take part in London Alternative Photographic Collective Sustainable Darkroom Residency, which is a 4-week project, with each week looking at a different aspect: recycle, remove, repurpose, and rework. I took part in week 1, which was recycle, which launched at the very beginning of lockdown. I was specifically on board with regards to silver reclamation from used photographic fixer. As it was the very start of lockdown, it really was a case of using whatever was immediately at hand. The first thing we looked into was resin-coated photographic paper. It can't be recycled due to the plastic coating. So the group was tasked to try making it into a paper pulp clay and experiment with it in that form. I also wanted to think of ways I could reuse it and extend the life of the paper within my own practice. And I'd recently been trying dry point etching using Tetra Pak packaging, which has a plastic coating on the inside. Dry point prints are made traditionally by scratching into the surface of a metal or acrylic plate, which is inked up and then printed from. I had a stash of very expired photochemicals and resin-coated paper from well over 10 years ago. So I used that to make some chemograms and try out the dry point technique with varying degrees of success. But now with a full tray of used fixer, I wanted to test whether it was possible to reclaim any of the silver from it on a very DIY domestic lockdown scale to reuse directly to make pieces of jewellery, or at least, very least, to be able to reclaim it in a state that it could be added to my stash to send off to the refiner. So precious metal plating is a very exacting and stringent process. Even when using specialised purpose-made plating solutions, like slight fluctuations can hugely affect the results depending on the specific chemical content and silver saturation of the solution, as well as all the many other variables. So using exhaustive photographic fixer was always going to be a little bit of a lottery. My original setup, shown here, was based on a method I found on a Dutch radio hobbyist's website, Rob Kilmeyer. And it was a very simple electrolysis setup. He was using 2 silver plate radio parts, and he just so happened to be using photographic fixer, specifically ammonium thiosulfate, as the source of the silver. This method felt as though it would be the most useful for me in terms of being able to directly plate pieces of jewellery with the least amount of processing or third-party involvement. So with sustainability in mind, I replaced his suggested 6-volt battery, torch battery, with a 6-volt lead-acid battery that could be recharged using a solar panel, and it is 100% recyclable. I also wanted to use as much as I could that I already had in my studio. So in the picture you can see the multimeter, which I actually borrowed from a neighbour because I couldn't find mine. In fact, the yellow one is my neighbour's, the red one is mine, and I prefer it, not just because of the colour. And I used, for the anode, I used a graphite stick from my drawing supplies. The cathode was some copper from some stock that I had in my studio. The single core cable was from a stash that I had I was going to recover the copper from. Bulldog clips from my studio, and a beaker made from a drinks bottle. And I just brought in the 10K pot variable resistor to adjust the amperage, and the battery. So my first trial was fairly successful. I used a very, very low amperage between 0.05 to 0.08, but the plating was quite easy to remove when polished in places. I tried a higher amperage between 0.2 to 0.3, and the plating was much more even and thicker and brighter. You can see the 2 tests on the piece here. However, it did tarnish a lot quicker from the sulfur in the fixer. One of the reasons jewellery tarnishes is because of sulfuric gases in the air, hydrogen sulfide being the most common. Sulfuric compounds are often used in the jewellery industry to patinate metals, such as liver of sulfur, which is potassium sulfide, or for a chemical-free option, just bung some jewellery in a bag of boiled eggs, which essentially accelerates the tarnishing, giving a grey or black finish, which is silver sulfide. It's worth mentioning actually at this point that electrolysis of the fixer at 2 higher amperages will generate hydrogen sulfide, which in large quantities is toxic. But in all cases, this work was done with appropriate PPE, ventilation and extraction, and the amps were kept low. So I turned this first piece into a very simple cuff bracelet, but I actually really loved the texture of the uneven plate, and the plating remained pretty stable and actually still is over 2 years later, so I'm going to take that as a win. I also continued to pursue ideas for reusing the resin-coated photographic paper in my jewellery, specifically reusing the failed chemograms and prints to create wearable photos in some way. I was interested in creating gemstones and a material from the photographs that still featured the structural and ephemeral characteristics of the paper and images printed onto them. I also wanted to make elements for jewellery from the photos that could then be plated from the fixer they were created from. And the result was this. So these are electroformed objects and elements for jewellery formed by moulding the pulped paper against parts of my hands, manipulating what were flat objects into 3D organic forms. Now, electroforming is basically, it's essentially very heavy plating. And in this case, using recycled copper as anodes. And then that left naturally to oxidize. In fact, I lost them for a while, and then they just went on their way and just looked like that afterwards, which was fantastic. So building upon these initial experiments, last year I decided to move away from my domestic lockdown DIY approach and instead use my studio electroforming equipment in order to more finely control some of the variables. As I said, silver plating is very sensitive to current, temperature, pH and agitation, and probably, if you look at it, funny. So it made sense that the next stage was to remove some of the inconsistencies in the hope of a more reliable result. I've been using my rectifier, which is a fine adjustable power supply, to set and monitor the amperage much more accurately, experimenting with the optimum normal plating ranges of 0.03 to 0.1 amps, so 30 to 100 milliamps per square inch of surface area. And my heated magnetic stirrer to keep the solution agitated and at temperatures of around between 47 to 55 degrees C. So the initial result was a series of small silver-plated sculptural forms to be used as jewellery elements. Silver-plated chemigram print and pieces of jewellery. This is one of a series of pieces that are sort of referencing the volcanic origins of the metal. All made from resin-coated paper. All of the last 3 photographs made from resin-coated paper, which were electroformed and then silver-plated from the fixer the photos originally emerged from. A kind of cyclical process of reuniting the silver and the paper. So all of this was still using the same batch of used fixer from 2020, but it was starting to deplete and plating had slowed down a lot. In fact, here you can probably just about see where the diffusion of the silver into the copper has started to occur due to the plating being thin. But I was lucky enough to receive a delivery of 12 litres of used fixer from Hannah Fletcher after the Sustainable Darkrooms workshops at Camp Wildfire last summer, which has been keeping me going for a bit. So here we have some silver-plated photo etchings, silver-plated chain, which is made from recycled copper pipe, and electroformed resin-coated paper brooch, which I left shiny this time. And there's a better image of the chain. So another discovery I made during my experimentations last year is that when I first started to use the rectifier with my original used fixer, there seemed to be a very fine line, finding the plating sweet spot and the current being too high, causing the formation of silver sulfide precipitate, which is like a black powder. So I believe this to be possibly due to the saturation of the silver in the solution. At this point, it was probably very low, and no matter how low I set the current, it would, for want of a better term, burn the silver and turn it into sulfides. It's important again to mention that this decomposition of the solution is what will off-gas the hydrogen sulfide, sorry. Having tested the other solutions that I was gifted, some appeared to work better than others. There is a very, very simple, although not massively accurate way of testing the silver saturation in the fixer, is to immerse a strip of brightly polished copper. And if there's a grey deposit after 5 seconds, you're probably good to go. 30 seconds is probably too low to even try to electroplate. I did some research on the recovery of silver from the silver sulfate itself, from the precipitate, and was able to use the small amount I'd filtered out the solution to smelt using fluxes and iron into the silver metal. So these are some test pieces. All the granulation, which are the little balls, were made directly from the silver recovered from the silver sulfide. The earrings, other than the posts, which are sterling silver posts, the earrings were made entirely from the silver recovered from the silver sulfide. Again, I need to stress, this was after extensive research and using full safety procedures. So another pair of earrings there, made entirely from silver metal from the silver sulfide. And I've recently been experimenting using damaged Polaroids to create an emulsion lift enamel effect on the jewellery, on the silver, exploring ideas of transference and preservation and loss. So in terms of my next steps, I've got a few more ideas from the ideas of potential collaborations from today's seminar. But in terms of my next steps, I'm really interested to see how reusable or replenishable the fixer is once it's almost completely depleted of the waste silver and filtered of any other sediment, in the hope to extend its lifespan. I know that electrolysis will only remove so much silver, especially on this scale, and there's a reason why expensive commercial cell units are available. But I'm thinking metal replacement as the last stage removal may recover what's left, which is another reclamation method used extensively in photography labs, and basically involves steel wool in a container with fixer, and after a period of time the iron replaces the silver, leaving silver as a sludge, which can then be sent off to be refined. There are also a few chemical methods for precipitating the rest of the silver out as silver sulfide, but I really want to do some more research on this, especially since I prefer to keep things as simple, clean and sustainable as possible. I'm hoping that this could potentially lead to the fixer being reunited with the original donor to use again in some form or other. I'm actually quite close to testing my first batch. It's really important to me to continue this work, as it opens up so many possibilities for further development within and beyond my practice, to produce better and consume less. It's my goal to ultimately create not only my own closed loop waste recycling system within my studio, but also as a means to collaborate with other artists and industries on a wider scale to share and manage our precious resources. Thank you.
Thank you very much, Charlotte. That was fascinating. We don't have any questions currently, but maybe if any questions occur to anyone, myself or Charlotte could answer afterwards. So I'm going to present some of the work created during the for the Photofusion exhibition. So I'll just get my presentation up. It's hiding currently. Magda Kuka says your work is amazing, Charlotte. Okay, so you should be able to see my screen now. So my name is Melanie King, and I am an artist and researcher. I'm in the last stages of my PhD at the Royal College of Art, and my thesis is titled Ancient Light, Rematerializing the Astronomical Images. I look at the relationships between astronomy, ecology, and photography. I'm also a lecturer in photography at Canterbury Christchurch University, and you can find me at Instagram and Twitter on those tags. So I recently presented this exhibition, Precious Metals at Photofusion in Brixton, and the exhibition has been going since the 17th of June and is open for one last day tomorrow. So if you haven't been to see it yet, it'd be really great if you would be able to go. So this is a culmination of about a year and a half's research. And I was very much inspired by Camilla Hansen's research on finding silver in supernova explosions, and this idea of silver being something that is finite on the Earth. Because silver is only made in high energy supernova explosions, once the silver has been removed from the Earth, we're not going to be able to get any more without having some kind of cosmic mining system. So it was very important to me to do a project which was about reclaiming silver and using silver and palladium in different ways. So some of the first explorations that I made were to use Charlotte Padgham's technique. So Charlotte and I met online in, I think it was February 2021, while it was still locked down, and Charlotte gave me a Zoom workshop showing me how to do the process, and that was extremely helpful. So I made a very similar setup in my garden and got some results that I was happy with. And then I sometime later worked with a jeweler called Laura, who is based in Margate, where I live, and she gave me a workshop on how to create metal jewellery. So at the same time, I was also doing a silversmith course at Margate Adult Education Centre. So Laura, or Goddessa Jewellery, generally makes jewellery which is inspired by goddesses, and due to this she also has many pieces of jewellery that are inspired by the sun, moon and stars. And we'd met in a studio in Margate and had kind of built an ongoing relationship from there. So we decided to make a set of pendants that were inspired by the cosmos. And then later on I went to the University of Birmingham over a couple of different months to work with Dr. Leah-Nani Alconcel, who you heard from earlier in the seminar. And if you weren't here before, Leah-Nani Alconcel works at the School of Metallurgy and Materials in Birmingham, and we were able to use the laboratories and to test out lots of different ampages. So we started with Charlotte's ampages as a reference, and then experimented with our own different levels of ampages. And eventually I think we stayed on 1 amp, and we were able to do this because we had access to a fuming hood. So the fuming hood was able to take out the hydrogen sulfide gas, filter it and let it go high up into the air. Hydrogen sulfide gas is also something that occurs naturally. It happens when seaweed is washed up on the beach, so it's not something that is not naturally occurring in nature. However, as Charlotte mentioned, you do need to be very respectful of it. So yes, we silver plated quite a few different pieces of jewellery from the photographic fixer, and had varying results. And this is a copper cuff that comes from old copper pipe that was eventually or was originating from when my partner made a fire organ. We also experimented using brass more recently. So this was in June 2022, just at the beginning of June. And we used some old clock faces and some other pieces of brass and used the same technique. And we found out that brass does work quite well because it's a composite, and the brass element has a slightly more conductive feature, so it makes the electroplating smoother and faster. So we're very excited about that, and you can see some of them a little bit better here. So this is these are some photographs from Derek Weave, who visited the exhibition early on in the run. And these are some of the jewellery pieces. So this is based on the Plough constellation, and then we have some kind of starbursts, which you can just about see in the right-hand side of the screen, that are kind of consistent with Godessa Jewellery's jewellery style. So I very much recommend checking out her website. And the silver came from the printing of these images. So these are silver gelatin photographs of the night sky from my Ancient Light series, and they're made using coffee developer. So it's made from coffee, vitamin C and soda crystals. And this is something that I worked on for a couple of months, just trying out different recipes and getting to know the process. So as you'll find with different sustainable photographic processes, some of them don't work in the same way that you expect other chemicals to. This is has some unexpected results. So the coffee is toning the print in some respects, and it's also a little harder to control. So when I use Coffee Developer, often the first print develops very fast, and then the preceding prints actually take between 5 and 10 minutes to develop. And as the developing time goes on, it can end up being more like 30 minutes. So that process of being in the darkroom, that kind of meditative process is extended. And I'm really interested more generally in the kind of slowness of photography and how that can put us into a reflective mindset. And then in the exhibition as well, I've also been using the cyanotype process. So someone earlier mentioned the potential for iron as a photographic process. So cyanotype is an iron-based process. If you've not heard of it, it's a 19th century technique, and it was invented by Sir John Herschel about in the 1850s around, and it's because it's iron-based, it doesn't use silver, and obviously iron is a lot more prevalent than silver is, and also at the same time it is ecologically friendly. So there's a really good PDF which is online and free called Cyanomicon by Mike Ware, which discusses the environmental credentials of cyanotype process. So I'd recommend checking that out. And these cyanotypes are toned with green tea, and they're also of the night sky in various locations around the UK and in Europe. So the previous photo that was taken at Hoya Art and Ecologica, which is a carbon neutral residency in Spain. And then this is from the Earth Space Residency, which was led by the BioArt Society in Finland. And we went to Kilpisjärvi, which is a very northern area of Lapland. And again, this as this cyanotype is working with organic material, the process is a little bit unpredictable, And that's something that I'm very much excited about within my practice. And I kind of see working with organic materials as kind of a collaboration with the more than human. And then as part of this project, I created some palladium prints of supernovae. So this is the Butterfly Nebula, and it's a NASA photograph printed using the platinum palladium technique. And this is something I've been looking into in terms of how to reclaim palladium in the alternative photography process. And this is something that Bostic and Sullivan have also been looking into in America. So that was the Elephant Trunk Nebula, and this is the Horsehead Nebula. And I just really wanted to tie the photographic back to the cosmic, as that's something that I'm very much interested in. And just to provide a bit of context about my Ancient Light series shown before, what I'm really interested in is this idea of light traveling for thousands, if not millions of years, and reaching photosensitive material. And as silver is made in the cosmos, it's almost like it's meeting itself when it meets the film, and I find that quite exciting. And then also with Dr. Leah-Nani Alconcel, in the lab, we also experimented with making silver nitrate and ascorbic acid crystallize under the microscope. So I particularly really wanted to learn more about silver and learn more about its materiality. So these are just some images that we created looking through the microscope, and it is absolutely fascinating because you can see these silver crystals being formed in real time. And for me, it really kind of shows the vitality of matter and shows photography as this very dynamic medium. And there's a text that I look at in my PhD, which is called Vibrant Matter, which talks about materiality having agency. And we kind of think of this in terms of pollution, but you can also physically see these materials responding to chemical environments in real time, and I find that absolutely fascinating. And as well, it's just beautiful to kind of see these amazing crystalline structures that are very strange and otherworldly with your own eyes. So I'll just share a few more of those images. So these are some installation shots from the exhibition. So we have the silver nitrate and ascorbic acid images that myself and Leah made on the left hand side. And then we have a rather large silver nitrate image, which was made with Dr. Simon Park. And then in the vitrine, there are some of the silver pieces that you saw earlier. And then on the right hand side, you have the Cazenave prints, which are purposefully put next to the jewellery to kind of highlight that connection between the prints and the silver jewellery, as the silver came from those prints. And then closer to the front of the screen, on the front of the lens, are the Cazenave cyanotypes. And then on one of the other walls, there is a series of daguerreotypes that were all of different supernovae. So we have the Pillars of Creation, and we also have the Bubble Nebula. And daguerreotypes is something that I've been experimenting with for at least 10 years. And I made these originally with Brenton West, who is a silversmith and a daguerreotypist. However, he's decided not to make daguerreotypes anymore. So there are other people who are filling in on that front, such as Joe Gain, who's been making daguerreotypes as well. So I really recommend checking out their work. But something about the daguerreotype which originally enchanted me was the idea that you can only see the image from one perspective. So you have to kind of really move around the print. And yeah, that was something I wanted to explore a little bit here. And then on the right hand side, you can see the palladium platinum prints of the supernovae. this is another view of the Cazenave prints and the green tea toned cyanotypes. And you can see that all these kind of very natural muted shades, which are not usually connected to photography. And these are a few more close-ups of the silver nitrate images. So as Charlotte mentioned before, this is coming out of the Sustainable Darkroom Residency, which happened in 2020, also in lockdown. And this is a book that was a result of this residency. And in this book is Charlotte's recipe, which is the one that we used, or me and Leah used as a basis. And then more recently, both myself and Charlotte have been collaborating or contributing to a book called Resource, which is a new publication by the London Alternative Photography Collective and the Sustainable Darkroom, mainly led by Hannah Fletcher, which is a really comprehensive tome, really, that shows lots of different sustainable photographic methods and how some of these ideas have been developed. So there's things like making bioplastic, and there's things like Rosemary Developer, and there's also a more detailed breakdown of the work that myself and Leah did, as well as Charlotte's more recent experimentation. So I really recommend checking that out on the londonaltphoto.com website. And then I just wanted to end showing a few more images of the jewellery that I created, and these images are by Shannon, who's hosting this seminar on for Photofusion, and these are some of her photographs from the exhibition. So you can see here another silver-plated piece of jewellery that was a collaboration with myself and Odessa Jewellery, and that's the one with the kind of star motif. And then coming into the center of the photograph, there's a Mona Lisa meteorite, which I have encased in eco silver, also inspired by Charlotte. And again, I wanted to kind of highlight that connection to cosmic materiality. And then in the right hand side of the corner, there are some eco silver rings, which were kind of me experimenting with jewelry making in the silversmithing course. And it's something that I found incredibly fascinating as a material to work with. I loved using the kind of tools and the fire and the hammers, and really connecting with that kind of ancient process of working with metal. And these are some more photographs of the pendants that were coated with silver from photographic fixer. And there's some more experiments that you can see at the back there. So these are some photographs from the exhibition opening, which was really fantastic. It was great to see lots of people who are also involved in sustainable darkroom processes, and also some of the Photofusion community, which as I kind of mentioned in the talk at the opening, I've been kind of working with Photofusion for quite a long time. So I started running workshops, I think in around 2014 in the darkroom, and then we've also done collaborative projects where we have a telescope on the roof and make Polaroids from people's iPhone pictures of the moon. So I'm going to stop there, and I just want to say thank you very much to everyone who's been involved in this seminar. It's been absolutely fascinating to hear from you all and to hear all of the different connections to silver. And also thank you to everyone who's joined. It would be great to hear some of your responses to this talk. So please get in touch with myself, Photofusion, or some of the other artists who've presented. So that just leaves me to say thank you, and I hope you all have a lovely weekend.